Hello, and welcome to Diver. Diver is a set of tools for the Eclipse development environment designed to help you locate and analyze features of Java software. We are going to spend the next few minutes showing you some of the new sequence diagram filtering features of the software. Today, we are interested in finding out how this simple Tetris game removes a line that the player has completed. Let me show you what I mean. Let's play the game for a little while, until a line is completed. Here, this is what we are looking for. Let's find out how Diver can help us to analyze what the software is doing at this moment. Before beginning this tutorial, we had already recorded two traces of the Tetris game shown in the Program Traces view. We can see by looking at the Properties view that this first trace contains a moment in which we filled a line in the Tetris game. The second trace is like the first, except we did not fill a line. Diver offers us ways of focusing the Eclipse UI on the Java code elements that are related to the fill line feature. Use this small yellow icon to activate the trace that contains the fill line feature. Activating the trace will filter the Package Explorer so that only the code elements contained in the trace are visible. However, we can see that there are still a lot of classes to look through. Diver offers a way to get rid of the noise. Remember that this second trace is like our first trace, except for that we never filled a line while playing the Tetris game. We can use the eye icon to remove the code elements contained in this trace from the Package Explorer. This should leave us with only the source code unique to filling a line in Tetris. We can see now that there are only 4 classes unique to filling a line. A quick browse brings us to a method that may be of interest. We can use the Diver sequence diagram view to analyze what happened when this method was called. Right-clicking on the method pops up a context menu which shows us that this method was called in thread number 4. Selecting the thread will open the sequence diagram and reveal to us the context in which the method was called. Here it is. By scanning the sequence diagram, we can see some information about the context of the method call. For example, we can see which conditions were true when the method was called, and that it happened in the 100th iteration of this loop, because of a timer event. Now let's get a bigger picture of the sequence diagram. Even though we have located an interesting method, the sequence diagram is still quite large. There may be a lot of information here that we don't need to look at. For example, this getPlayer method on the game class is visible in the sequence diagram, but not in the Package Explorer. This is because the sequence diagram view isn't filtered by default. If we look at the Program Traces view, we see that there is a closed eye icon on our second trace. Our first trace has an open eye. Looking at the sequence diagram view, we can also see an open eye. Closing the eye will enable filtering in the sequence diagram. The filters will at first show us which method calls are not part of the fill line feature by graying them out. We can see that there are a lot of grayed method calls here. We can use this action to hide them from the view completely. Filtering the sequence diagram in this way has greatly reduced its size. Let's look at just how much the size is really reduced. Remember that our method is called within a loop that we can see here. Let's turn off sequence diagram filtering. By default, Diver compacts loop iterations so that only one iteration of a loop is seen at a time. Here we can see that there are more than 100 iterations of our loop. You can swap loop iterations using this context menu. To get a better picture of just how big this sequence diagram is, let's turn off loop compaction. Now we can see all of the loop iterations at once. This shows us just how large the sequence diagram actually is. Let's turn sequence diagram filtering back on. As you can see, there is now only one iteration of the loop visible. All other iterations are empty. Right-clicking on the loop will show us that there is in fact only one iteration in which our method is called. Thank you for watching. We hope Diver will help you the next time you need to understand your Java software.